Hi students, hope you guys are fine. So today I have brought a session of class 10 mathematics chapter 1 real numbers. So without wasting time, let us hop on to the first exercise, which is exercise 1.1. So our first question is to express the following numbers in the factor form. So first subdivision states 140. 140 has factors of 2s, 5 and 7. So 140 is equal to 2 into 2 into 5 into 7. So the next subdivision is 156 and the third subdivision is 3825. Moving with 156. 156 is prime factorized by using 2, 3, 13. So factor of 156 is 2 into 2 into 3 into 13. So 3825 is a number which is divisible by 5. During prime factorization, please make sure that all the numbers are properly divisible by the following numbers. If you made any mistakes on the particular step, your HCF and LCF will also go wrong. So for 3825, the factors are 5 into 5 into 5 into 17 into 3. The fourth subdivision is 5005 and the fifth subdivision is 7429. The numbers which are divisible by 5 always ends with 0 or with a 5-digit number. So it has factors of 11, 7, 5, 13, etc. For 7, 4, 5, 2, 9, we have factors in a prime number format. So the factors are 17, 19 and 23. So our second question is to find the LCM and HCF of the particular number and also verify the following. So the first subdivision states 26 and 91. So 26 and 91, we would go with the LCM and HCF in a single prime factorization. For your convenience, you can also go by doing the prime factorization of 26 and 91 separately too. So the HCF is 13 and the LCM is 14 into 13. You can either multiply and get the final number or keep it in a product method itself for the easier way of multiplication during the verification process. Here we are introduced to a new formula which is LCM into HCF is equal to the product of the two numbers or the three numbers which has been given. So 14 into 13 into 13 is equal to 26 into 91. 13 square is 169. And the final number would be 2366. And both the LHS and the RHS are having the same digit, hence proved. These questions are more seen in the 2 mark questions of many exams. So let's move with the second subdivision, which is 510 and 92. So the HCF of it is 4 and LCM is 4 into 6 into 21 into 23. So during the verification process, let's see whether the LHS is equal to the RHS one. So the final digit would be the product of 84 into 24 into 26. 46920 is the LHS and the RHS, thereby it's also proved. The third subdivision is 336 and 54. 336 and 54 are both even digits, so we can also go with 2. And in prime factorization, you have to make sure that every single number you use should be a prime number. Using composite number will not be appropriate. The HCF is 6 and the LCM is the product of 16 into 27 into 7. During your exams, please do not skip the steps actually. All these steps would have marks. So 18144 is the LHS and the RHS, and thereby it's been proved. For the third question, they are asking us to find the LCM and HCF by applying the prime factorization method. So 12, 15 and 21 is our first subdivision. The HCF of it is 3 and the LCM is 420. For the second subdivision, we are being given as 17, 23 and 29. Here, there is a hint actually given in the question itself. If the following numbers are prime number and if they are non-consecutive, prime numbers usually have their HCF as 1. So you can directly find the HCF, and these types of questions are mostly expected in 1 marks. And the LCM is 11339. And the third subdivision is 8, 9 and 25. So we are being given with another question having composite numbers, but they do not have any common factors. So their HCF will also be 1. Let's see with the LCM now. One eight double zero is the LCM. Moving with the fourth question, in which the HCF is given as 9 and the numbers whose products we have to find is 306 and 657, and we are asked to find the LCM of the following one. By using the formula of the verification process, which is the product of the two numbers is equal to the HCF and HCM's product, we would be able to find the LCM or HCF which is not been given in the following given data. So the LCM would be the product of 102 into 219, 22338 is the LCM of this question. So we are being given with the fifth question stating if 6 to the whole power of n can be expressed in the form of 0. So we are being introduced to a new concept right now, which is a theorem called as fundamental theorem of arithmetics. Fundamental theorem of arithmetic states that every composite number is expressed in the form of prime numbers. For example, if imagine that we will take the smallest composite number, which is 4. 4 is being expressed in the form of 2 into 2, whereas 2 is a prime number. So this is what this theorem states. And in this question, the theorem consists of 1 mark, and the following explanation would be having a 1 mark. Thereby, it's mostly expressed or asked in the 2 mark question. It's an exponent formula of an is equal to a into b the whole power of n. So 6 can be expressed in the form of the product of 3 and 2. And for getting a number having an n digit of 0, we need a combination of 2 and 5, which is not there in this set. So 6 and would not end with 0. This is what the explanation that the board seeks from every student. So the seventh question is, they have asked us to find whether the following given numbers, why are they composite number? And with using the same theorem present in this chapter, fundamental theorem of arithmetics, we can find that 13 is being common in this subdivision. So we know that um, 13 is a prime number. So while taking 13 as common, you can find 7 into 11 into 1 plus 1. 1 is neither prime nor composite. Thereby, it's mostly in the product of prime numbers. And we can say that the following question would end up with a composite number. So moving with the second subdivision, 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. We are being asked to prove this as a composite number. By the same theorem, we can find that 5 is being repeated and 5 is a prime number. We would be taking 5 as common, and the rest of the numbers would be expressed in the form of prime numbers. Thereby, it would also be a composite number. This would be the explanation to this particular question. So we have a seventh question, which is being given the details about Sonia and Ravi who are cycling around a park. Sonia takes 18 minutes to ride one round in the circular path, whereas Ravi takes 12 minutes. So we are being asked that they both start from the same point at the same time and go in the same direction. So by how much minutes they would be meeting again? So for this, we have to take the LCM of the following numbers. By taking the LCM, we can find the time in which they meet together. These types of questions are being asked in the boards. Thereby, they would meet in the next 36 minutes. Thank you, students. So let's meet with the next video.